In this presentation, we are going to show you another factoring technique for trinomials called the AC method. Earlier, we learned what to do with a trinomial when a is equal to 1. It was a very simple process. We could just take c, find multiples of c that added up to equal b. But now we need to learn if a isn't equal to 1 anymore. And that's where the AC method comes in. When a is greater than 1, we're going to use the AC method to solve a problem. So when it's equal to 1, we could just use a equals 1 method. AC method was what we're going to use for a is greater than 1. Now, if a is less than 1, we're also going to use the AC method, but we're going to have to do a little bit of work ahead of time. So as you can see, I've given you an example where, in this case, a is -5, and we are still going to use the AC method, but first we're going to have to factor out a negative from the term. As you can see here, I've now factored out the negative, and I'm left with 5x squared minus 10x plus 12. Now you see that a is now equal to 5. We can use the AC method to factor this problem now. So I'm going to go through step by step and show you an example of how to do the AC method. The example I'm going to do for you is 8x squared plus 13x minus 6. Step 1, you're going to find two numbers that multiply to AC that have to add up to equal the b term. Again, we're going to keep in mind that the subtraction signs as negatives. So in this case, c is going to actually be -6. So take a look here. I've clearly defined a is 8, b is 13, c is -6. We'll find two numbers that multiply to AC. AC is 8 times -6, which is -48. So they have to multiply to -48 and add up to b, which is 13. So as you can see here, I've listed out two numbers that multiply to equal 48. I've got 5 combinations, and I am trying to find one that will get me to b, which is 13. So I have chosen 16 and 3, and the only way to get to 13 with 16 and 3 is a -3 plus 16. And then go back, you can check, -3 times 16 is -48, and -3 plus 16 is 13. So that works for this problem. Step 2, it's a little bit different from the a equals 1 method here. With the a equals 1 method, we were able to go and get our answer right away. Now we're going to have to take it a little bit further. We're going to rewrite the middle term as the two numbers that we have just found from step 1. Okay? So in this case, we're going to be attacking the 13x because the 13x is the middle term. So originally we had 8x squared plus 13x minus 6. Take a look at what happens when we rewrite it. So as you can see, we've taken the 13x and we've replaced it. It's now been replaced by the -3x plus 16x. We got those from what we got at step 1, the -3 and the 16, that made the 48. This type of polynomial should look very familiar to you. It is now a 4-term polynomial, so if you think back, what could we use to factor a 4-term polynomial? Well, that's what step 3 is going to help us find. You can see with step 3, now we're going to use our grouping technique to finish the factoring. So AC method always leads us right into grouping. So as you can see here, I've grouped the two terms up. From the first group, I factored out an x. The second group, I factored out a 2. Notice, again, just like we've said before, with grouping, the parentheses are the same, both 8x minus 3. That is what we want when we do grouping, and we get our final answer of x plus 2 and 8x minus 3. So this is our technique for doing the AC method. Let's go ahead and show you a couple of other examples of the AC method. So here I'm going to take 5x squared minus 9x plus 4, and I'm going to factor it using the AC method. Again, the reason I'm using the AC method is because a is bigger than 1. In this case, a is 5. So a times c, 5 times 4, that gives me 20. I'm looking for a multiple of 20 that adds up to -9. The only one that I could come up with was 4 and 5, and the only way it could add up to be negative 9 was negative 4 minus 5. And again, negative 4 times negative 5, a negative times a negative, we are going to get back to a positive number, so that does give us positive 20. Now, as you can see here, I did take the middle term and I did rewrite it as the two terms that we just found, but you notice this time I didn't write it in the order that I had listed it over on to the right. I actually wrote the negative 5 first and the negative 4 second. And I did that for a reason, because when I go to group, because I know grouping is the next step, I want the 5s to be next to each other and I want the 4s to be next to each other. So you can go ahead and group these in any order you want. The middle terms are interchangeable. It's up to you how you want to write it. So again, you see here now with my groups, I've got the 5s grouped together, I've got the 4s grouped together. From the first group, I can factor out a 5x. I'm left with x minus 1. If you look here again, you can pick up on one of the techniques. You've got a minus sign in that first group that we factored out. You've got a plus sign in that second group we're about to factor out. Different signs, we're going to factor out a negative number when we do it with this second group. So the second group has a 4 in common. I'm just going to factor it out as a negative 4. And again, you'll see by doing that, I'm left with x minus 1 once again in the parentheses. Again, we want the same thing in the parentheses in order to know that we did AC method successfully. So in this case, my answer is 5x minus 4 and x minus 1. Okay. Our next example shows us that we always need to make sure we look to take out the greatest common factor before we do any sort of factoring. So we've got 20z squared plus 26zw minus 28w squared. If you look at that, something should pop out to you, and you should notice that all the numbers are divisible by 2. So that at least means that we have a GCF of at least 2. So again, I notice that they're all even, so I know that I could at least use the GCF and factor out a 2. So I do factor out a 2, and that leaves me with 10z squared plus 13zw minus 14w squared. I still have to do the AC method. I'm just going to do it on the part in the parentheses, but it makes it a little bit easier because now I'm working with smaller numbers than 10 and 14 as opposed to working. So we'll go through the AC method again. A times C is 10 times negative 14, which gives me negative 140. I want it to equal 13. 7 times 20 is 140. The only way to get it to equal 13 is if I have a positive 20 and a negative 7. And again, a negative times a positive does give me a negative, so it does come out to give me negative 140. Once again, I'm going to switch the 20 and put it closer to the 10. I'm going to put the 7 closer to the 14 because 10 and 20 are common factors. 7 and 14 are common factors. It makes grouping a lot easier. Also notice, because the middle term had a ZW, both my new middle terms have a ZW. Whatever the variables are there in the middle term, that's what our two new middle terms are going to get. Again, pretty straightforward factoring here. We can factor out a 10z from the first group. We can factor out a negative 7w. We know it's a negative because of the little trick we learned earlier. Both times it leaves me with z plus 2w inside. So we go to write our answer. The only thing we have to make sure was included in our answer is what we factored out earlier. So that is why we have a 2 in front. So it's 2 times 10z minus 7w, z plus 2w is our final answer. Now, you can see here, I call this slide AC method with GCF, but I put a question mark. Because again, this is why you want to look for the GCF ahead of time. You look at this problem, 3x squared plus 12x minus 15, you think to yourself, a is 3, a is bigger than 1, I have to use AC method. But you also realize 3, 12, and 15, they are all multiples of 3, so I should be able to use the greatest common factor here. So I do. I use the greatest common factor. I factor out a 3, and that leaves me with x squared plus 4x minus 5. Well, now take a look. A is no longer 3. A is equal to 1. So now I don't have to use AC method. I can use the A equals 1 method to do this problem, which is a lot simpler. All we need to find is something that multiplies to C and adds up to B. So the only thing that multiplies to negative 5 is 5 and 1, and because it's got to equal positive 4, we'll have a positive 5 and a negative 1. So again, we'll write our answer just like we would at the A equals 1 method, x minus 1, x plus 5. We just have the 3 on the outside from what we factored out earlier. So again, this is just showing you that make sure you look for the GCF anytime before you start the AC method. It could lead you back to A equals 1 method. It could let you do the AC method a little bit easier. So hopefully with this video, you can now successfully use the AC method.